Okay.
Okay, rolling. All right, so we're on the second part of the lab. The last part, I'd say we had mixed success because it looked like the forces weren't exactly equal and opposite, but I kind of suspect that's due to the fact that the force sensors probably weren't calibrated exactly. So even though if the forces were the same, maybe they didn't read the same because the force sensors weren't calibrated exactly right. Also, they were kind of shifted compared to each other a little bit on the horizontal axis on the time scale. And the reason that is because when this is collecting data, the lab pro is collecting data, it uses what's called a multiplexer, which basically collects from one sensor and then the other sensor and then the one sensor and then the other sensor. So because it can only really collect one data point at a time. So even if there's two forces that are simultaneous, it assigns one to one time and the next to a slightly different time. So I suspect that might have something to do with it, but I'm not sure. In the second experiment, what we're going to be doing is looking at Newton's second law, which is claiming that an object's momentum changes and when there's a force acting on it, and there's a specific relationship between the change in momentum and the force acting on it over time. So what I'm going to do is we have a force sensor set up here, and we also have this cone. It's a reflecting cone, and at the other end of the lab bench, we've got this this motion detector. It's an ultrasonic motion detector that's going to send out clicks of sound, kind of like a bat does for sonar. It bounces off this cone and then comes back, and by timing how long it takes to get there and back, it deduces the distance between that sensor and the cart. And by doing this repeatedly, it's going to do distance measurements of this cart along the track. And then from the information about its distance and how the distance is changing with time, we can figure out the velocity of this cart. And if we know the velocity and if we know the mass of this, then we know the momentum of this. So notice that right now this cart has zero momentum, because remember, momentum is mass times velocity. Its velocity is zero, so there's zero momentum. I'm going to apply a force to this. The force sensor is going to detect my force applied to it and how much time I'm applying to it, applying that force. And then it's going to start it moving. And the motion detector is going to measure the speed after I push it. And so by finding the speed before I push it, and hence the momentum before I push it, which is zero, and the speed after I push it, and the momentum after I push it, I can get the change in momentum. And that change in momentum should be equal to the force integrated over time. So the force at each time that I'm applying a force to it. Okay? So I'm going to go ahead and collect the data. I'm going to say collect, and we'll see how this goes. Okay. And why don't we pause there for a minute?